Okay, consider a Ferris wheel. Try to draw a nice round circle here. And we want this Ferris wheel to have radius 1 unit, whatever that is. And of course, if the radius is 1, we know the circumference of the circle is 2 pi times r. We just said r is equal to 1. So this is just 2 pi times 1, which is just 2 pi. Pi is a number a little bit bigger than 3. .1415, whatever. We know it's an irrational number. So 2 pi is a number a little bit bigger than 6. I want this Ferris wheel to be rotating at speed 1. So if we're going at speed 1, since it's 2 pi units, a little bit more than 6 units of distance all the way around, and we're going at speed 1 unit of distance per unit of time, it takes us a little bit more than 6 units of time to go all the way around. Okay, so here's where things get a little silly. This Ferris wheel has only one car on it. Only one thing you can ride in. And this Ferris wheel is half submerged in water. By the way, you get on right there. So it's half submerged in water. You're going around, you're going around, going around, going around, hold your breath, and keep going all the way around. And this one car is all lit up. And it's night. So we're going around in this nice lit up car. We go underwater. Water's crystal clear, so you can see through it. You can see this car go under the water, come back up, it keeps going around, and so on. Now, unless you like holding your breath on a Ferris wheel, maybe you wisely say to your friend, okay, I'm just going to watch from over here. You go on the Ferris wheel. So we're going to watch from way over here. So this is where you're standing, watching the whole thing. And since it's night, and this is the part that's lit up, all you see is this lit up car that your friend's riding on going up and down. We can't see it go in a circle because we're watching from over here. If we were watching from over here, sort of face onto the Ferris wheel, we could see it going around in a circle. But all we see is this little light. When that thing goes up, we see the light go up in the, up above the ground, and then we see it go below the water. I guess we can see through the ground here. So maybe this is all water. And we're just going to watch that thing go up and down. So I want to make a graph of what we see. So the highest this thing ever gets is height 1, because we said the radius was 1. And the lowest it ever gets sorry, these lines are a little wonky. I'm sure yours are nice and perfectly straight. Lowest it ever gets is height -1. Again, the radius is 1. And we said we start right here. You get on at sea level, so you start at this height. So this axis is going to be time. We're going to keep track of the height that we see this thing. That's all we can see. We can only see the height of that car. We can't tell when it's closest to us over here and far away over here because we're watching from way over there. All we see is this thing lit up. We can tell if it's up or we can tell if it's down, but we can't tell if it's near or far. So at time 0, when our friend gets on, it's right here. This thing is rotating at 1 unit, so it takes 2 pi units to go all the way around, but to get up to the top, it only takes a quarter of that. A quarter of 2 pi, so 2 pi divided by 4 is pi over 2. So it takes pi over 2 units for it to get to the top. At pi over 2, so pi over 2, pi is a little bit bigger than 3, so pi over 2 is a little bit bigger than 1.5. So let me say that's 1 unit, so there's 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units, 1, 2, 3, 4, 5, 6. So pi over 2 is a little bit bigger than 1.5. There's pi over 2. And our friend gets on at sea level, but by pi over 2, they're up at the top of the ride. We can see they're up at the top of the ride. And in another pi over 2, so when we get all the way to pi, our friend has gone from over here to over here, and now they're about to go underwater, but they're at sea level again. That's what we can see. So by the time we get to pi, so pi is a little bit bigger than 3, they're at sea level again. In another pi over 2 units, they're down at the bottom of the ride. So that's 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2 takes them to the bottom. So 3 pi over 2 is a little bit bigger than 4.5. They're at the bottom here. And by 2 pi, they've gone once all the way around. 2 pi is a little bit bigger than the number 6. So 2 pi, they're back where they went, and they keep going. So in another 2 pi units, they'd be at the top, and so on. Now, when the ride starts going, all this rotational velocity is going up. It's going uphill, and we can see that. When it gets near the top, most of the rotational velocity is taking the ride away from us. We can't see it move away from us. All we can see is the up-down motion. So it's rising faster at first, and then it's rising slower and slower as it gets to the top. Even though it's going at the same speed, most of that rotational motion is horizontal now. When we start off, it's mostly vertical. So we start rising faster, and then we slow down near the top. So if we're sketching the height, it's faster at first, and then as we get near the top, it slows down. And then you can see we're still going up here, but much slower than we were over here. And then we peak here and start going down again, faster and faster. I don't know how good a picture this is. I'm sure yours looks much nicer. So nice and smooth. And then we start going down under the water. And then back where we start. And this just keeps going forever. Up, down, up, down. And so the vertical component of this motion around in a circle we call the sine curve. This graph that we've started to graph here, and it continues in both directions, up, down, oscillating infinitely, is called the sine curve. And a curve that's shaped like a sine curve or a cosine curve is called a sinusoidal function. It's just that general shape, that nice wavy shape. And this is why we spend so much time talking about sine curves and cosine curves, because they are just one dimension of this very natural motion in a circle. I want to talk a little bit more about the sine curve before I draw the cosine curve for you. This distance from the middle of the sine curve to the top, 1 unit. It's the same distance as it is from the middle of the sine curve to the bottom. It's 1 unit. And this 1 and that 1, that's called the amplitude. The amplitude of the sine curve is equal to 1. The time it takes to complete 1 cycle before the whole thing repeats takes 2 pi units. So 2 pi, that's a perfectly nice number. It's a little bit bigger than 6. So 2 times 3.1415 is about 6.282, whatever. This is called a period. The time it takes to complete one cycle. So the amplitude, which is again the distance from the middle to the top and the middle to the bottom, a very common mistake is people think that the amplitude is the distance from the bottom to the top. It's not. It's half the distance from the bottom to the top. So it's the distance from the middle to the top and the middle to the bottom. That's called the amplitude. And the period is the time it takes to make one complete cycle. And so the period is 2 pi. All right, so let me just draw a smaller version of that. Oh, I guess before I do that, I don't have to draw a smaller version. I still have room on the board. Before I erase anything, I want to point out that just because we happen to plot numbers like pi over 2 and pi and 3 pi over 2 and 2 pi on the curve doesn't mean like numbers like 1 and 2 and 3 and 4 and 5 and 6 aren't still there. They're certainly still there. The only reason we happen to plot pi over 2 is because something interesting on the curve happens at x equals pi over 2. That's where we hit the top of the curve. Nothing particularly interesting is happening at x equals 1, or t equals 1, xt, whatever you want to call the horizontal axis. We're partway up the curve. Big deal. We're also partway up the curve here. But at pi over 2, we're at the top. At 3, nothing particularly interesting is happening. We're most of the way back down again. But at pi, a little bit more than 3, we're crossing the x-axis or the t-axis or whatever you want to call the horizontal axis. So the reason we mark these points is because that's where something interesting on the curve is happening. Let me just sketch below what the cosine curve looks like. So this was y equals sine x. I guess I can put it even on the same picture. I'll do it in what I assume is blue. So the cosine curve is another sinusoidal curve. Instead of starting in the middle like the sine curve does, the cosine curve starts at the top. But it has the same general shape. By pi over 2, it's in the middle. At pi, it's at the bottom. At 3 pi over 2, it's back in the middle. At 2 pi, we're back where we start at the top. And the cosine curve looks like this. It's got exactly the same wavy shape as the sine curve does. It's just shifted over. The cosine curve and the sine curve have exactly the same shape. They're just shifts of one another. But the cosine curve starts at the top and the sine curve starts in the middle. So this is y equals cosine of x. And this is y equals sine of x. And they both come from circular motion.